A very good morning to all the students. I am Dr. Hima Bindu from the Department of Mechanical Engineering from Institute of Aeronautical Engineering, and I'll be dealing the subject robotics, and my today's topic is machine learning in robotics. In the previous sessions, we have learned about the various soft robotics, RAN robotics, human-robot interactions, and we have solved few problems on links and rotational matrices. So in today's class, we will be discussing about the machine learning in robotics, because as we all know, machine learning is one of the new trend which is being followed by all the interdisciplinary technology institutes. So here, what is the use of machine learning and how can machine learning help in robotics? That we will be discussing in today's session. Right. So what do we mean by machine learning initially? What happens in machine learning? That is, in robotics, machine learning is used to enable the robots to learn from the data, or it is used to make decisions and improve their performance over a period of time. Right? When there is a time gap, when we have a time for the improvement to be done. So that we need to insert machine learning into the robotics such that it will generate the data and it can make its own decision. That is, it can learn from the data and make its decision and improve over the period of time. Right? Improve its performance over the period of time. That is the use of machine learning when we are inserting that into the robotics. Now, this particular integration has to be done based on the significant achievements on the robot applications such as autonomous navigation or object recognition, or when we come across the human-robot interaction. This is very important, right? Human-robot interaction is very important, where machine learning plays a very vital role. Right, whether we need to recognize an object, or when we need to do a manipulation, or when we come across autonomous navigation, machine learning plays a very important role. As the machine learning algorithm and the computational power is used to advance the integration of the machine learning, not only in not only in the growth or leading or the for the capable robotics, but it is also used to enhance the interaction with the human. Right? So it is the broader application which is used in the fields of diversity. Right? So here the machine learning algorithm is very important, where it where it is computed for a powerful continuous and advance of the integration machine learning. Right? The key areas or the key applications which comes under the machine learning topic in robotics is that the object recognition. Object recognition is very important, or the sense understanding, or the sensor fusion. So these are some of the few important perceptions which are very important, and that is the reason why machine learning is being initiated in the design and manufacturing of the robots nowadays. That is, neural networking, that is CNN, is one of the concept which makes the robot easy to understand, or it makes the robot easy to identify and classify the objects in its environment. Right? With the help of the CNN or the neural networking, right, a robot it becomes easy for the robot to identify the various objects or to identify whatever is being surrounded in its particular environment. So that is very important in terms of object recognition. So in that way, we will be writing an algorithm in terms of machine learning, and that we will be imparting it in our robot. Next, when we come across sense understanding, the sense understanding is also one of the complex that it plays a very important role for understanding the complex senses. which play a crucial task like navigation and manipulation. When we come across the navigation and manipulation problem, the sense understanding is very important. And next, coming to the sensor fusion. Sensor, we already know what is the use of a sensor and why is it required. Mostly in any robot, the sensor, whatever we are using, will generally be a camera or a IMU or a LI lidar, right? Lidar, right? So here, these are the new machine learning techniques to improve the accuracy, right? Other than the camera, MIUs and lidar are one of the new technologies with the help of which the robot will improve its accuracy. That is the machine MI techniques which has been introduced in form of sensor. Right, so these are the key areas, we call it key area of application where machine learning is playing an important role. Next, planning and control. Without any proper planning or without any proper control, we cannot do any particular activity, right? So path planning is very important, right? Other than path planning, we need to also have a motion control. When there is no control, when the robot is moving, right? When there is no motion control for the robot when it is moving, then that particular robot will not be in its sense and we don't know what activity it is doing. So we need to have a correct path planning and we need to also have a control on the motion and we also should have a control on the manipulation, right? That is when the MI algorithm is being written or when a particular reinforced learning algorithm is being written and imparted in the robot, it should opt for a path in a dynamic or as well as the unknown environment. In such a way, we need to insert an algorithm or we need to write an algorithm for the robot. Or when we come across the motion control, the machine learning techniques is used to refine the control or to ensure the smooth and precise movement. In order to have a good, smooth and precise movement, we should write an algorithm where we have a control on the robot. Or when we come across the objects, manipulated objects or varying shape, size and weight, the supervised learning or the reinforced learning comes into action, right? When we need to, the robot has to learn the various shapes, it have to have an idea of the sizes, it should have an idea of the weights. So all that will be taken care with the help of the reinforced learning. So these are the new techniques which are coming day by day, which we need to implement in the upcoming robot design and construction, right? Next is the location and mapping. Localization and mapping. What do we mean by localization and mapping? That is SLAM. We also call it as SLAM. That is simultaneous localization and mapping. What do we mean by that? What do we mean by the term SLAM? That is, here the SLAM algorithm is being written for the unknown environment, right? The SLAM algorithm is being written for the unknown environment to update the maps, right? Or to keep the track of its location. That is, the algorithm which is used for improving the robot ability to create the updated maps of the unknown environment or to keep the track of its location. The localization and mapping is very important. The SLAM is very important. Next is extraction, feature extraction. That is, as I've told you, the environment plays a better role, and that is localization accuracy. That is, using machine learning, we extract and utilize the features from the environment for better localization accuracy. Or when we are coming across self-driving or when we are coming across drone navigation, the machine learning plays a very important, like the Tesla car. We have an example of a Tesla car. It is a self-driving car. When we are not giving a proper algorithm to that particular Tesla car, can it operate accurately? Does that particular car know when the signal is being done or when the particular person is crossing the road? So all that programming should be given in detail so that it doesn't harm or it doesn't violate any of the safety rules. So here, when we impart deep learning into this, we can get a decision making and a control on that particular robot, right? When we are imparting deep learning with a proper perspective, we can get a decision making robot, good decision making robot, and we can also have a control on that particular robot, right? Or when we are coming across the drone navigation, generally drone navigations are being used nowadays mostly in the agriculture fields, right? So when we are imparting the program to that particular drone navigation also, we need to give a program in such a way that it should have a proper path planning. It should know what is the obstacles and how it can avoid the obstacles, and it should act as an aerial vehicle, that is unmanned aerial vehicle, right? Next, coming to the human-robot interaction, this already we have discussed in the previous session. What is the use of the human-robot interaction and all. So, speech recognition, gesture recognition, and emotional detection are very important concepts in the human-robot interaction. Next, coming to the machine learning techniques in robotics. What are the various machine learning techniques in robotics? That is supervised learning or unsupervised learning, right? We have come across continuous and uncontinuous learning. So in the same way here we have supervised learning and unsupervised learning. That is, a robot should have a learning skill which is labeled, which is having already labeled data, right? That is available data. Or it should have a support of a vector machine, that is a support vector machines, or a decision tree, or a neural networking also act as a common algorithm which comes for the supervising learning. Or when we come across the unsupervised learning, the k-mean clustering or the principal component analysis autoencoder are one of the common algorithms which we will be using, right? Next, coming to the reinforced learning, that is RL. What do we mean by reinforced learning? RL means it is nothing but the common algorithm for the RL writing is deep Q network, proximal, or Q learning. Or we also can consider policy optimization. So these are the main important common algorithms which can be used when we are using reinforced learning. That is, when we come across the trial and error method, or when we come across the maximum cultivated rewards, we can use this particular type of the algorithms, right? Next is the deep learning. What do we mean by deep learning? Deep learning, generally we come across CNN or RNN. That is one for the image data and one for the sequential data. When we come across the image data, we will be using CNN. When we come across the sequential data, we will be using the RNN, right? Or the complex sequential pattern also can be done with the help of the deep learning technique. That is, when we come across the networks for high dimensional data processing, deep learning is very important, right? When we come across the high dimensional data processing, the deep learning is very important, and the image data will be done with CNN and the sequential data will be done with the RNN. What are the feature directions and challenges which we come across the machine learning in robotics? So one of the most important one is data requirement. Without the data requirements, we cannot do anything. That is, large amount of data is used for training the machine learning models, which can be difficult to obtain in robotics, right? When we come across large organizations, or when we come across the educational institutes, there the data requirement is very important. So the large amount of the high quality data are required for training the ML models. So that is the data requirement. That is one of the challenge which we need to consider when we are manufacturing a robot. Or computational resources. That is, here again we need to come across a significant computational power and efficient algorithm. Right? When we come across the significant computational power and efficient algorithm, the machine learning model plays a very important role in training. Right, the machine learning model plays a very important role in training the robot. Or when we come across the new unseen environment, right? So generalization is also important, right? When we come across the unseen environment, the generalization technique is also important. The machine learning drive robot plays a very important role in safety and reliability. When we come across safety and reliability, it includes the privacy, or it includes the autonomous robot, or it includes the simplification of autonomous robot. All these are under the safety and ethics, which we have discussed in ethics and safety in the earlier session. Right, the IoT, Internet of Things, the 5G technology, or the edge computing are few of the recent trends, that is upcoming new technologies, where we can insert that also into our robot. So in today's class in machine learning, we have discussed what are the various challenges and what are the various future directions. Like, we can also use Internet of Things, we can come across 5G, and now we are going up to 6G. In order to enhance the robot capabilities, we need to use new trends and technologies like neural networking, CNN, RNN, or Internet of Things, or 5G, 6G technologies, right? Which are very emerging nowadays. So using these new trends and technologies, there will be a lot of variation to be done in the particular prescribed organization of the institute, right? So this is all about the machine learning in robotics. Hope you have understood this concept, right? So these are the references which we have gone through. So in the next class, we will be discussing the next topic. Signing off for today, Dr. G. Hima Bindu. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.